3 minutes are going to give a video about conventional grid and smart grid based on DT. I am here to give the empathy part about conventional grid. In conventional grid, there are many drawbacks like man-made errors. If any fault occurs in the conventional grid, we can find automatically. There are so many power thefts occurs in smart grid, so we can move to smart grid. The next part will be explained by Mr. Abhishek. Thank you.
Then here to say about the smart grid. When we are comparing conventional and the smart grid, the smart grid has its own smart technologies such as sensors and some power electronic devices which helps in detection of faults in a very easier manner, and also which can help in preventing of theft in current. Now when you are coming to the smart grid, the distributed generation plays a main role in the smart grid. When we are coming to the smart grid with the distributed generation, the main part is from thermal power plant, solar power, wind power and nuclear power plant. These four different type of power plants generates their own energy and used to the smart grid through a grid known as microgrid. The microgrid is used for giving the power from the particular power plant to the smart grid. The microgrid and the smart grid will be having a small connection which is known as feeder. The feeder is used to connect the microgrid and the smart grid. The microgrid which has the power from the power plant, it will be feeding the power to the feeder, and from the feeder the power will be sent to the smart grid. This is the way where the distributed generation plays a main role in the smart grid. Now when we are coming to the two-way communication, that is the industrial plants, cities, offices, smart homes and electric vehicles. When we are coming to the electric vehicles, there is a technology known as V2G technology, that is vehicle to grid, where the vehicle to grid system is like the power generated from the EVs can be sent to the smart grids using a microgrid, which we have been spoken in the past. And we are checking the smart houses, cities and offices. As we said, this is a two-way communication system. The power from the smart grid can be sent to the industry, cities and smart houses through the distributions like such as transformers and the local substations. It can also be reverted, like it can be reversed to the smart grid using the solar. When we are comparing the solar and wind, which we can produce from our homes or industrial plants which are in a huge size, it can be using the same technology where we can use the microgrid and send it to the smart grid. And when we are giving the conclusion for the smart grid, comparing this conventional and smart grid, the main thing is that it works in a very efficient and effective manner. Thank you.
Hello everyone, I am going to tell about key points. So environmental impact: reduce the dependency on a fossil fuel by integrating a renewable energy sources, helps a balanced grid loading, reducing the need for a peaker plants, often a carbon intensive. Efficiency energy management: EVs act as a mobile energy storage, useful during a peak demand times, enhance grid stability and resilience. Economy benefits: EVs owner can earn money by selling excess energy back to the grid, reduce the energy costs for both utility and consumers. Technology and infrastructures: require smart grid system by directional charge and communication protocols, still in early stages of deployment. Is a challenge and concerns. Degradation due to frequent charging and discharging. Regularity requires a sufficient investment in our infrastructure. Future potential: can play a major role in a sustainable urban planning. Integral to the smart cities and IoT driven energy system. Potential to support a disaster recovery by supplying a power in an emergency. Advantages of a V2G: grid stabilization. EVs can supply a power during a peak demand, reducing strain on the grid. Economical Environment benefits support a low carbon energy system, reducing a reliance on fossil fuels. Disadvantage of V2G, battery degradation. Frequent discharge cycles can reduce the lifespan of EV batteries. High infrastructure costs require investment in bi-directional charge, smart meters and software system. Regularity and standardization issue. Lack of consistent policies and technical standards. Widespread adoption. Limited awareness. Many EV users are unaware of V2G benefits or due to a technical complexity. Thank you.